The final topic that we cover in derivatives is derivatives of our inverse trig functions. We do four of them. We do sine, we do cosine, we do tangent, and then we do secant. That's what our book does. For the AP exam, I would say the basic three, the sine, cosine, and tangent, are definitely the ones you need to focus on. So let's go. The derivative of the inverse sine, or sometimes called the arc sine, remember, and I'm just going to generalize this, so I'll put a function u right there, is given by 1 over the square root of 1 minus u squared times the derivative of that function du dx. So if I wanted to find the derivative of, say, the derivative of the inverse sine of 2x plus 1, it would be 1 over the square root of 1 minus 2x plus 1 squared times 2. And the biggest problem people would have is that they wouldn't square out that binomial. Or if I squared out the binomial, like if it was a multiple choice question, I squared out the binomial and I simplified it, many people would get it wrong. So let's complete this. It's 2 over the square root of, remember when you square the binomial, it's 1 minus the whole thing. When I square this, I square the 2x, so I get 4x squared. The middle term is twice their product. 2x times 1 is 2x, twice their product is 4x, so it's plus 4x. And then the last term is the second term squared. And then probably distribute that negative, combine like terms, and I'd ultimately end up with 2 over the square root of negative 4x squared minus 4x. What you're going to find in calculus often, especially on the AP exam and all that stuff, is that the algebra skills really get in the way of getting the right answer. The calculus concepts are not that bad, but the algebra gets really pretty rough. The second derivative on the inverse trig function is our inverse cosine. And I'll just get you the patterns on a few of these, and then I'll do some different examples. The second one for inverse cosine, the derivative of inverse cosine, is going to be the same as the sine, but it's negative. So it's negative 1 over the square root of 1 minus u squared times du dx. That's a u squared. It's not very good, is it? The third one, the inverse tangent. This is the one that I have seen on the AP exam more often than the others. I'm not really sure why that's true, but that's what I have witnessed. It's going to be 1 over u squared plus 1 times du dx. And then finally, like I said, our book does secant, so I'll include that. I have never seen this one on the AP exam, however. And that's going to be 1 over u times the square root of u squared minus 1 times du over dx. One of the things I give you, or one of the things you'll face in problems here, is some differences in notation, and we got to recall from our pre-calculus days and then some of the other stuff we've done the difference in these. So we have, if we do this, we have, let's say, the tangent of x to the negative 1 power, or 1 over x, the tangent, inverse tangent of x, and then the reciprocal of tangent. And that's the way I would write these three. Now on this first one, if I were to take the derivative, I have to use chain rule. On this second one, I would apply the rule that I just gave you for the inverse tangent. And on this third one, this is really cotangent. So ultimately, if I did my derivatives on each of these, this would be the derivative of tangent is secant squared of x to the negative 1 times the derivative of x to the negative 1, which is going to be negative x to the negative 2, which I'll write as a fraction in just a moment. The derivative of inverse tangent is that I just showed you is 1 over x squared plus 1. This one is the derivative of cotangent. The derivative of cotangent is negative cosecant squared. You got to remember all those derivatives we did from a while back. And then really the only simplifying is I could put this part right here in a fraction. So I could write it as like the secant squared of x to the negative 1. Let's make all that negative, and that's over x squared. I made all of it negative there because of that negative right there. And then the middle term stays the same. And then the last one is minus cosecant squared of x. And that's not going to change. So it's like you can't simplify these fractions at all. You just leave it like that. It's kind of nonsense, but just difference in notation. So good luck on the inverse trig functions, and we're kind of done with the derivatives. In our next unit, after we get through a test on this, we're going to get into applying all these derivatives. Good luck.